In this video, we will talk about how to graph step functions. So let's say we have this function right here, y is equal to, these bars right here indicate the greatest integer function, or sometimes they're called the floor function. And sometimes instead of these bars, they're written in this format, but they mean the same thing, so just keep that in mind. So let's say we have y is equal to the greatest integer function of x. What that means is that whatever we plug in here for x, these bars tell us to take the next greatest integer, or sometimes we say the floor. So for example, if x was equal to, let's say 4.3, if we plug it into this function right here, that tells us we need to round down to the next greatest integer. So we'd say the next greatest integer, or the floor of x, would be 4. So we're going from 4.3 to round down to 4. Or if we had, let's say, x is equal to 7.999, if we took the greatest integer function of x, we would get 7. So we're rounding down to the next greatest integer. Or if we had, let's say, x is equal to negative 3.54, if we're rounding down, so if we take the next greatest integer of x, we would round down to negative 4, so the next greatest integer. So knowing that, let's see how we could actually graph this function. So if we would like to graph this function right here, it really helps if we can create a table of x and y values. So if x is equal to 0, and we plug that in for 0 right here, the next greatest integer function says round down to the next nearest integer. Well, 0 is already an integer, so y would just be 0, so it doesn't change at all. But let's say we had 0.5. If we plug that in for x right here, then we're going to round down to 0. So we would return a 0 for y. Or even if we had something like 0.99, if we plug that in for x right here, we're still going to round down to 0. But let's say we plug in a 1 for x. Well, to round down to the next nearest integer, that would just be 1. So y would be 1. And the same process will repeat. So if we had 1.99 and we plug that in for x, we would round down to 1. So y would be equal to 1. And then as soon as we hit 2 for x, we're going to return a 2 for y, because 2 is already an integer. So rounding it down would keep it as a 2. So if we were to plot these values over here, we would say we'd have the value x is 0 and y is 0. So that's the origin right here. And we said when x is 0.5, y is also 0. So we'd imagine that when x is 0.5, so right here, y is still 0. And even when x is 0.99, y is still 0, so we're getting really close to 1. But all of these values between here are just y is equal to 0. So we usually like to draw a line like this. And notice that as soon as we plug in a 1 for x, we all of a sudden jump up to 1 for y. So once we get to 1, we jump up here, so we can put a shaded in circle right here, and then we can draw an open circle right here to indicate that when x is equal to 1, y is no longer equal to 0, y jumps up to 1. And then we'll see this process, this kind of pattern right here repeat again. So we said even when x is equal to 1.99, so like all the way over here, we said y is still going to be equal to 1, so it will still be 1, and everything in between, all these x values, y is still going to return a 1. But as soon as we reach an x value of 2, we jump up to a y value of 2. So as soon as we get to 2, we jump up again to a y value of 2. And we draw another open circle right here to indicate that when x is equal to 2, it's no longer equal to a y value of 1. It jumps up to 2. And what we'll find is this pattern just repeats over and over again. So we'll jump up right here, and we'll keep going kind of in this staircase or this step pattern. And even when we go below the x-axis, this pattern will continue where there's an open circle here, we draw a line, there's a closed circle here, an open circle here, and we'll just continue on and on like that. So we can see it kind of looks like a staircase, or you can imagine you can take steps up, hence the name a step function. So that's how we could graph that function, and often we call this function right here the parent function, because if we know how to graph this parent function, then we can easily figure out how to graph other variations of it. So let's check out a couple examples. All right, let's say we want to graph this function here. Y is equal to the next greatest integer function of x plus 2. Well, again, it helps if we can make a table of x, y values. So if we plug in a 0 for x, and we plug in a 0 right here, the next greatest integer, or rounding down, would just produce a 0 again. So we would have 0 plus 2, which is just 2. Now, what if we plug in a 0.9 for x? If we plug in a 0.9 right here, this tells us round down to the next integer, which would be 0, and then we add 2 again, so we still get a 2. But once x hits a value of 1, when we plug in a 1 right here, this just returns a 1, so we have 1 plus 3, which is 3. And we'll see that the pattern continues. So if we had a 1.9 and we plug that in for x, that would still round down to 1, and then we would add 2, which would be 3. And as soon as we hit 2 for x, we'd plug in a 2 right here, it still returns a 2, and then we add 2, which is 4. So if we go to graph these values, we'll find when x is 0, y is 2. So that would be right here. And then we said when x is 0.9, so it's getting really close to 1, y is still equal to a value of 2. So everything in between here is still a y value of 2. But as soon as we hit an x value of 1, we jump up to y is 3. So when x is 1, y jumps up here to 3. We can draw an open circle right here. And this pattern will just continue. So what we'll find is that when we have this step function like this, so the next greatest integer function plus some value, it just shifts the whole graph up by this number. So we're going up by 2. So if we were to continue this graph, we would see that it looks something like this. And we'll notice from the parent function, it's the exact same graph, but just shifted all of the values up by 2. Now, if this was a negative 2, if this was a minus 2, then it would shift all the values down by 2 compared to the parent function. So keep that in mind. All right, let's try one more example. Let's say we have y is equal to the next greatest integer function of 2x. So how could we graph this? Well, again, let's create a table of x, y values. So if we plug in a 0 for x, we get 0 times 2, which is just 0, and rounded down would still produce a value of 0. What if we plug in a value of 0.4? So this would be 0.4 times 2, which is 0.8, and we'd still round down to a 0, so we'd still get a 0. But what if we plugged in a value of 0.5 for x? We would get 0.5 times 2, which is 1, and we'll notice that rounding 1 down to the next integer is just 1. So in this case, as soon as we hit an x value of 0.5, we've already jumped up to a y value of 1. Now if we keep going, if we go up to, let's say, 0.9, if we plug that in here, we get 0.9 times 2 is 1.8, and rounding that down to the next integer would just be a 1. But as soon as we hit an x value of 1, if we plug in a 1 right here, we get 2 times 1, which is 2, and if we take the next greatest integer, that would still just be 2. So we jump up to 2. All right, so if we go to graph these values, we said x is 0 and y is 0, so that's the origin. When x is 0.4, y is still equal to 0, so like right here. All of these values in between here, for x, they still have a y value of 0. But as soon as we hit an x value of 0.5, we jump up to 1 for the y value. So right here we'll put an open circle and we jump up to 1 as soon as x hits 0.5. And then we carry on until, notice that when x hits 1, we then jump up to 2 for the y value. So when x is 1, y jumps up here to 2, and we'll put an open circle right here. So notice what has happened with the graph compared to the parent function. We've basically compressed it, where we've squeezed it a little closer. So we only have to travel to x is 0.5 until we jump up to the next y value. And what you'll find when you have this type of pattern with the step function is the greater this value is, the more the graph is compressed, or the shorter that each of these bars are right here. Now, if we had a number that was even less than 1 right here, so if this was like a 0.5, then it would stretch out the graph, where these bars would be even longer. They'd be even longer like that. So keep that in mind when you have a value in front of the x. So these were just a few examples of how to graph different types of step functions. And no matter what type of function you're given, you can always create an XY table of values like this to kind of help you get an idea of how to actually graph the function.